Alrighty, in this video we're going to start Chapter 1, Section 1, and that just covers the graphs of equations. And we're going to sketch a graph of an equation by point plotting. So if possible, we rewrite the equation so that one of the variables is isolated on one side of the equation. Usually we solve for y. Y equals something. And then we make a table of values showing several solution points. So we'll make a little table, and we'll have our x and y column. And you know, whatever's over here with x's in it, we'll plug in different numbers for x. We can pick numbers like -1, 0, 1, 2. We pick the x values, plug them in, and see what y values pop out. So we make that table showing several solution points. We plot the points on the rectangular coordinate system. Remember, this is your x and y axis. A point is x comma y. And we connect the points with a smooth curve or maybe a straight line, depending on the function. So we're going to start here. First, we're just going to determine if solutions are points. We're going to give you some points, and you're going to figure out if they are a solution to the graph. So here it says determine whether point A, 2, 13, and B, -1, -3, lie on the graph of this. Y equals 10x minus 7. So it's y equals x is to the first power. That tells me it's going to be a straight line. And all they're asking us to do here is plug in these points and see if they are in fact on the line. So here our x value is 2, our y value is 13. So I'm going to replace y with the 13. I'm going to replace the x with the 2. And I'm going to see if this is a true statement. Does 13 equal this? Well, 2 times 10 is 20. And 20 minus 7 is 13. And 13 does equal 13, so check. Yes, this point is on the graph. If I graphed the line, this would be a point on the line. And for part B, we're going to use the same equation, y equals 10x minus 7. And I'm going to plug in the point -1, -3. So y is -3 and x is -1, and we'll see if that is true. So does -1 equal 10 times -1 is -10 minus 7. -10 minus 7, that's sort of like adding the opposite. So we get -1 equals -17. Is that a point on the line? No. Does not compute. Doesn't work. So again, if I graphed this line, this point 2, 13 would be on it, but this point -1, -3 would not. And here in example 3, we're just going to sketch the graph of the equation. So our function is already set up, y equals, and it's equal to x squared minus 2. Now in the previous example, I said that this was a x to the first power, so that was going to be a straight line. If you see a squared power as your highest, that's a quadratic, and it's going to be shaped like a parabola. If it's positive x squared, it'll open up. If it's negative x squared, it'll open down. So definitely here, because of the squared part of that function, also I want to plug in some negative and positive values. Let's try some positive values first. Or good place to always start with 0. If I plug in 0, 0 squared is 0, minus 2 is -2. If I plug in a positive 1, 1 squared is 1, 1 minus 2 is -1. Plug in a 2. 2 squared is 4, 4 minus 2 is 2. And let's go 3. 3 squared is 9, minus 2 is 7. So here's some points to start with. 0, -2, 0 on the x-axis down to -2 on the y. 1 on the x, -1 on the y, over 1, down 1. Next point would be 2, 2, over 2, up 2, and then over 3, up 7. And that would be slightly off the graph about up here. But we're only about half done. Remember, because that is squared, any negative values would turn positive. So if I plug in -1, -1 squared is 1, minus 2 is -1. If we plug in -2, -2 squared is 4, 4 minus 2 is 2. If I plug in -3, -3 squared is 9, 9 minus 2 is 7. Look at that, we got the exact same y values for our negative x values. This point, -1, -1, over 1, down 1. -2, up 2, over to -2, up 2. And -3, +7. So if we connect these points with a smooth curve, it's not going to be a straight line. We have this parabola opening up on the left of the y-axis, or the right of the y-axis, and also on the left of the or y-axis. So we got this parabolic curve opening up with a y-intercept of -2. Remember, if it's squared, it's going to be parabolically shaped. Always check some positive and negative x values. So the point plotting method in that example is easy to use, but it does have its shortcomings. With too few solution points, you can misrepresent the graph of an equation. For instance, if you graph these 4 points, maybe one student is going to look at those 4 points and see this type of shape, like a downward opening, almost a volcano shape or hole shape. Another student might look at those exact 4 same points and think, oh, well, that's a circle centered at 2 on the y-axis. And a different student might look at those same 4 points and say, oh, that's a parabolic curve opening up. So, it does have its shortcomings. The more points, the better. Or if you have a good understanding of what the basic shape of a graph is, that helps to connect the points in between the points that you actually plot, that you graph. Okay, when we graph things in the coordinate plane on the xy axis, some of the interesting points are where those graphs cross the x's and the y axes. So it's often easy to determine the solution points that have 0, either as their x or their y coordinate. These points are called the intercepts because they are the points at which the graph intersects or touches the x and y axes. It is possible for a graph to have no intercepts, one intercept, several, as shown in the following figures. So in the first one, we have a parabola opening up. It only hits the y-axis once. It never touches the x-axis. No x-intercept, only one y. On the next one, if we look at the x-axis, we cross the x-axis here, here, and here. So it has 3 x-intercepts. And then if we look at the y-axis, a common intersection point is right here at the origin. So we would count that also as one y-intercept. Here in the third one, on the y-axis, we cross twice, 2 y-intercepts, but here we only have 1 x-intercept. And it's also possible to have no intercepts at all on either axis. We could do that by graphing a circle. Example 4. Here in the book, it says, identifying x and y intercepts. Identify the x and y intercepts of the graph of this equation. First power functions are straight lines. Squared functions are quadratics, or going to be shaped like parabolas. If you have an x to the 3rd power, it's kind of like we took an upward opening parabola and we snapped it off right here and bent this side down. So the very basic x to the 3rd graph will go up into the 1st quadrant and it will go down into the 3rd quadrant. Up to the right, down to the left. And for this one, it does say identify the x and y intercepts of the graph of this. So if they give you the graph, sometimes our intercepts are right on those main number lines, and we can figure out exactly where they cross. Here we can see on the y-axis, we cross at y equals 1. And if we look across the x-axis, we cross right here at x is -1. So if possible, you might be able to pick those off the graph. We could also do it algebraically. We could take, to find the x-axis, or x-intercept, we would set this y equal to 0 and solve for x. Or if we wanted to find the other intercept, we could solve for y when we set x equal to 0. So, just think about each variable gets a turn being equal to 0. Here, y is equal to 0, and we solve for x. Here, 0, or x is equal to 0, and y is what we're solving for. So for the first one I did here in blue, if we solve this, we would subtract 1 from each side. X to the 3rd equals -1. And we could take the 3rd root of each side. That's 3rd root. So here the root and the exponent cancel. X equals the 3rd root of -1 is -1. So x equals -1. That's our x-intercept right here. And for the other one, this is easier. 0 to the 3rd is 0. Plus 1 is y equals +1. That is our y-intercept. Here's our y-axis. Go to +1. There's where we cross the y-axis. On example 7, we're going to sketch another graph, and here, you might not have seen this before, you might have touched on this in Algebra 2, our absolute value of x minus 1. We want to be careful with the x minus 1, or the absolute value bars, mean the graph is going to have a V shape. It's going to hit somewhere and go back up, maybe down here and go back up. Sometimes it'll hit right on the x-axis and go back up. We really want to make sure we get enough points to figure out what's going on with this graph. So let's see here. Let's start our x at -3. Plug in -3. -3 minus 1 is -4. The absolute value bars make it positive. -3 up 4. -2. -2 minus 1 is -3. The bars make it positive 3. So -2 up 3. -1 in for x. -1 minus 1 is -2. The bars make it positive. So -1 up 2. Plug in a 0. 0 minus 1 is -1, and the bars make it positive 1. 0 up 1. Now, if you stop right there and thought, okay, I know a good idea here is just going to be a straight line, I can just finish the graph right now. Absolutely not. The absolute value bars are going to make it bounce off something. It is going to start to head back up somewhere. Let's plug in 1. 1 minus 1 is 0. The absolute value of 0 is 0. So 0 or over 1 up 0. Let's plug in 2. 2 minus 1 is 1, and the absolute value bars make it 1. 2 comma 1, so we go over 2 up 1. 3. 3 minus 1 is 2. The absolute value bars keep it positive, so over 3 up 2. Now we're getting a good idea what's going on with the graph. We are going to pop down here. It's like we hit the x-axis and we bounce off it and head back up. It's not always the x-axis. You know, we could put a -3 after the absolute value bars. That would shift the whole graph down here to -3. So just make sure absolute value bars, you do want to find where you have sort of a check mark shape. You know, it's not just going to be a straight line. Make sure you're checking enough points. And that brings us to the practice problem. So stop the video, you know, plug these points in here, see if those points do in fact lie on the graph. Number 18, graph that shape, 5 minus x squared. And the last one is graphically estimate the x and y intercepts of the graph. So give those a shot and then start the video back up and see if you got them right. Alright, let's see how we did here. Let me get some of this out of the way. The first one, plug in the points, see if they're on the graph. You know, if we were to graph this equation, would these points be on the graph? So this is our x comma y. We want to plug in 2 for y. Does that equal the square root of 5 minus our x value of 1? Well, 5 minus 1 is 4. So the root of 4, does the square root of 4 equal 2? Yes, it does. Check. That is on the graph. Yes. Next, let's plug in 5 comma 0. Our y value is 0, so 0 equals the square root of 5 minus x, or 5 minus 5. Does 0 equal the square root of 0? Yes, it does. Check. Both of these points lie on the graph. Number 18 here is complete the table. Use the resulting solution to sketch the graph. Let me make my graph paper a little bit bigger. There we go. And here's nice. They did give us the x values already. So it is 5 minus whatever this is squared. So 5 minus -2 squared is 4. 5 minus 1 is 1. So they want us to write the point here, x comma y, -2 comma 1. And let's graph it right now. -2 up 1. Next, let's plug in -1. 5 minus -1 squared is 1. 5 minus 1 is 4. -1 comma 4 is our point. -1 up 4. Next, plug in 0. 5 minus 0 squared is 5 minus 0, or 5. 0 comma 5 is a point. Left and right 0 up 5. Next, y is 1. 1 minus, or 5 minus 1 squared is 4. Over 1 up 4. Plug in the 2. 5 minus 2 squared is 5 minus 4, or 1. 2 comma 1. 2 comma 1. That should have been 1 comma 4. So 2 comma 1 over 2 up 1. This is 5 minus x squared. Remember when I said x squared, positive x squared is a parabola opening up. Even though the x squared term is written second, we could rewrite it as negative x squared plus 5. That negative tells us our parabola is opening downward, and that's exactly what we see here. We cross the y-axis at 5, and our parabola opens down. Oops. So the last one, it says graphically estimate. Let's see what we can do with that one. So this is kind of a weird function. We have in parentheses x minus 3, that quantity squared. So what is our x-intercept? Do we touch the x-axis? So let's look at the graph. X-axis right here. Do we touch it? Do we cross it? Yeah, it looks like we cross right there. What's a good bet at that point? Right between 2 and 4 has got to be 3. Let's check our y-intercept. Does this look like we cross our y-intercept? It's kind of hard to tell, is it at 8? Is it at 10? If I was a betting man, I'd try to bet, maybe it's right in the middle there at 9. And let's see if we can check this algebraically. Here is our original function. Let me see if I can move this over here. Remember, we let each variable take a turn being 0. So can I let y equal 0? 0 equals x minus 3 quantity squared. So to solve this, to get rid of this squared, I would square root each side. The square root of 0 is 0, and we get x minus 3. Add that negative 3 to both sides, and we get x equals 3. There's the algebraic backup of our x-intercept. And now let's go the other direction. Y equals quantity 0 minus 3 quantity squared. Well, 0 minus 3 is negative 3. Negative 3 squared is 9, and that's what we estimated from the graph. Our y-intercept is 9. That was the harder one to see, though. So, the graph is good, but a little algebra is even better. All right, that wraps up the first day. The assignment for this section is the worksheet. I should have passed that out for you in class.